Thank you guys for having me here. I've been delighted to be attending these seminars for the past few weeks and glad to be presenting here. Who am I? I am a Berkeley PhD. I am former director of the Kinoma team at Marvell Semiconductor. We're going to talk about that quite a bit. I am co-founder of Moddable Tech, which is a JavaScript for embedded company, which we're going to talk about a fair bit. Co-author of the ECMA 419 JavaScript for Embedded Systems API, visiting faculty at UC Berkeley, and currently curler in residence of Rock Creek Curling. Undeniably a curling professional, arguably a professional curler. Depends on the day. To start things off here, I just want to ask a quick question. What objects in your life, like in your home, in your car, in your office, are most meaningful to you?
My pillow.
Good one. Hopefully, yeah.
My phone.
Okay, what about your phone?
It has my life in there.
Yeah, okay,
My calendar,
good.
my emails.
Cameras, very good.
Olivia raised her hand.
I have really specific spatulas, I think.
Ooh, interesting.
Yeah.
Where do they come from?
They actually came from a kids cooking subscription service called Radish.
Fun. I love that.
That's good.
I like them the best.
Anybody else?
My notepad.
Say again?
Notepad.
Okay, very good. And that's something that, you know, again, kind of like her phone is organizing your life, that sort of thing. Nobody's given me the softball answer yet. Somebody else.
I don't know if coffee is the salt.
I left my coffee in the car with Lizzie, so we'll see how I do on getting through this.
Not a softball.
There you go. Hey, thank you. All right, we got there eventually. So for a lot of people, the things that are kind of most meaningful to them are things that came from another person, things that were built or made or drawn, created, influenced in some way by some other person. And this talk is going to be kind of about how to bring that notion of, you know, creative influence into the world of IoT. Got a lot to get through. I will just go and we'll see how much of this we actually get through. I'll jump around a little bit, but some quick kind of definitions. If you're not familiar, what is IoT? That's the Internet of Things. That is smart devices, things that are typically have a microcontroller or a full-on CPU in them and are often, but not always, connected to the internet or have onboard sensors. It's a $700 billion market, depending on how you count things. It's getting trickier and trickier to count what is IoT because so much has computing built into it at this point that basically all white goods sales count as IoT. But it's a $700 billion market growing towards $4 trillion. There are about 20 billion connected devices currently in operation. And the market looks like consumer, connected to consumer electronics, industrial, medical, and automotive. I am going to focus mostly on connected consumer electronics today. And then one bit of background that you need to know in life for this rest of this talk to make sense is that there was a company called Kinoma. It's right here.
Yeah.
They existed since 2002. Building JavaScript engines for extremely resource-constrained devices. So they started building device software for Sony consumer electronics. If you had like a Sony camcorder or a Sony still camera in the mid-2000s, that had Kinoma software on it. They eventually went into the phone software world and then kind of built out from there, running on Android, iOS, macOS, Linux. They got acquired in 2010 by a giant semiconductor company called Marvell Semiconductor. And around that time, I got hired there, asked to just kind of come in and be, my job title was user experience architect, but the idea was to be kind of a creative technologist, to come in and figure out things to do with the Kinoma platform on this Marvell hardware and see where we could take it that wasn't a phone platform. She made it. Hooray. You're doing better than Olivia still. Olivia's still circling around out there somewhere.
Look at her.
Yes. So I came into Kinoma and did a bunch of little projects here and there. I helped build a bunch of their software for mobile platforms, prototype some connected consumer electronics devices. But the first real big idea that I hit on was a thing called Kinoma Create. And we'll see if my audio works here, but do we need to unmute that?
Hey, I'm Peter,
No.
and this is Kinoma World Headquarters. Kinoma Create is the next wave of hardware for creating consumer electronics products, and the driving force behind Kinoma Create is Andy.
Hi, I'm Andy, and this is Kinoma Create. Today, bringing your product concept to life can be a real challenge. You could spend days, weeks, or even months dealing with C, Linux drivers, and reading sensor manuals. And if you don't know how to use those tools, you might as well just forget it. We've made all of this simpler for you by integrating the hardware and software and letting you skip those steps and get right to the fun stuff. Because our platform is built on top of JavaScript, all the things that you would expect to be easy really are just that easy. That includes working with internet services, discovering other devices, and drawing your user interface. We've also extended JavaScript to make it just as easy to work with the hardware components of the device. That includes things like the I2C bus, UART, and GPIOs.
Hi, I'm Valkyrie Savage,
I'm Evan Savage.
and we built Hoedown, an immersive cowboy game.
Valkyrie's now
The way
HCI
the game works
faculty in
is that we have a
Copenhagen.
series of sensors attached to the Kinoma Create, and we use those sensors to measure the different ability scores.
What I like about the Kinoma Create is wireless programming. It gives me the chance to move around and think in different spaces without tripping over the cables that connect me to the device.
The
As a
year
web
is
developer, I work with
2014.
JavaScript a lot. Having a common language really helps me understand the things that I'm doing.
I'm building an aquarium monitoring and control system using a Kinoma Create. The sensor integration in general has been very easy, and I was able to pull them out of the box, have them wired to the Create, not only have them connected, but reading values into my software really integrated in 20, 30 minutes.
So what we're showing off here is one more application built on top of Kinoma Create. It's an alarm clock that uses sensors and the internet to tell you more about your environment. But as you can see here, we use a 3D accelerometer to determine what side of the screen is up and which way to draw it. And if you look on this screen, you can see that we use an ambient temperature sensor to determine the temperature of the room, and we pull the high and low temperature for your area from the internet. Kinoma Create includes everything you need to get your project up and running. That includes a capacitive touchscreen, Wi-Fi and Bluetooth, a speaker and microphone, a battery, USB OTG, a micro SD card, and a serial console port. Another aspect of Kinoma Create's
I'm not gonna
usability
watch
is we
this
put a lot of thought
We're
into
getting there.
the industrial design of the product.
Mostly I
We
just wanted to
decided to
get
do
you back.
something totally different. All this enclosed in an integrated package that lends portability to your projects and polish to your demos.
Kinoma Create's front-facing pins have been built to accept a variety of common sensors. And if you need more, there's a 50-pin connector on the back. So that's the hardware, but what about the software?
Kinoma Studio is a development environment for Kinoma Create. With Kinoma Studio, you can also build companion applications that communicates with your device using iOS or Android. I can use a companion app on my phone to control it. The best part is you can do this all with JavaScript, so you don't have to be a hardware hacker to build cool things.
Crowdfunding is the catalyst behind so much of the innovation that's happening in consumer electronics today. We're launching our Kinoma Create campaign to contribute to that community by making things easier for future creators.
So now that you know what you get from Kinoma, the real question is, what will you create?
Thank you for being a part of this.
So 2014, we launched this crowdfunding campaign to try to bring this wacky plastic thing that I had envisioned out into the world. And that was a weird thing to do at the time. It would still be a weird thing to do now. We were at a $1 billion semiconductor company, and we pitched it around to media at the time as exploring the space, trying to get people interested, trying to build some momentum, gauge interest in how much people actually wanted this thing. And we got some pretty good press out of that. We got a Wall Street Journal article out of it. We got a lot of coverage, people talking about it. Truth of the matter is that Marvell wasn't interested in building this product, and I wanted to. And so we were looking for a way to kind of get this thing out the door that could plausibly actually happen. And so we did this crowdfunding campaign. We went out there, we raised whatever, 500 times what our ostensible, goal was. But it was a small amount of money. We raised like $60-ish thousand for building this thing. Took about 120 orders through Indiegogo. And then had pre-orders of about another 60 to 100 units. So we ended up bringing in about $120,000 to get this thing built. And get it built we did. There I am with my tower of boxes fresh off the boat from China. And we had a big product launch and we did the whole thing. And it actually went out into the world. So this is an example of a gentleman named Ken Howell who took Kinoma Create, strapped it to his hang glider, put a bunch of sensors on it, and was actually like reading out data from a Kinoma Create in real time, while in flight. And he said that was no big deal. Like he could just like hover there for a little bit and like reprogram it in mid-flight, and it was just kind of part of the fun. We ended up being chosen as the technology platform for WIST's Student Innovation Contest in 2014, which was super fun. That was the year WIST was in Hawaii, so I got to go to Hawaii for the trip, and we had dozens and dozens of student teams from all over the country building interesting stuff on top of our platform. I got to hire in many interns over the course of the next 3 years, including one from right here, either an Atlas student or a CS student, but from Boulder, that I called my makers in residence, which is where I've gotten my job title at Rock Creek from. But we built a lot of cool stuff. It was kind of magic for a couple of years where we had tons of people out there using this platform like you would use a Raspberry Pi or an Arduino or a BeagleBone, and kind of getting up and running really quickly, building cool things and sharing them with each other. Because that really was my inspiration for this project, was to get people building small consumer electronics and then gifting them. The thing about like a Raspberry Pi or an Arduino is that most people never get to like an acceptable form factor on it. They build some cool prototype, but it's wires and sensors and breadboards and everything going everywhere. I wanted you to be able to hand something to somebody and say like, look, I built you an alarm clock that's just for you. I built you a whatever that's just for you, and kind of do that sort of work. And when we really motivated people to do it by either paying them or having the student innovation contest or like getting people really jazzed up about it, it did work. We got reviewed by Make Magazine. We won a nice award from Make in 2016. And this is kind of heart of the maker movement stuff, when like everybody was really excited about this, gung-ho and going out there and like building cool things. There were problems. One of them is that this product was insanely expensive. This retailed in 2015 for $150, which was a lot of money then and now. And compared to many of our competitors, we were in a different bracket. We were at $130 more than an Arduino, basically. And so you had to really want one of these things if you were going to buy it. And the dirty secret of Kinoma Create is that every time I sold one, I was losing $10 because these cost $160 to build. And it was just kind of a mess in terms of the financials of it. If any of y'all have any like industrial design or product design expertise, can you guess any reasons this thing was so damned expensive to build? Molding. So I spent more on injection molding molds than I made in my crowdfunding campaign. The molds were $60,000 and we did not just do one iteration.
Timing is everything.
Yeah.
Did you build 10,000?
No, we built like a horrible number. We built like 2,000, which is even worse. Yeah, so that kills you.
Yeah.
One other horrible thing that comes with putting this in plastic, in addition to the molding. Heat. You're close. You're heading in the right direction. It's that you have to clear it with the FCC once you put it in plastic. And so we literally spent $200,000 to do emissions testing on this thing because we couldn't get it out the door. You know, if we had been just me in a garage, I would have taken that chance and like let the FCC come for me. But that was never gonna happen at Marvell. Like, you know, they had billions of dollars on the line. And so we had to play it by the book. We had to get this thing emissions tested. We had to do drop testing. I remember, you know, I lived in this building and I walk in one day and there's like a guy in a lab coat, literally like throwing Kinoma Creates at the wall. I'm like, cool, science, love whatever this is. How much am I paying you? And that's how this project went. Like we were just burning money.
That definitely sounds like the Columbia Labs. I didn't say that.
Now, I will tell you that it was kind of okay. And Lizzie, you're excluded from answering this question because you were there, but can anybody guess why it was kind of okay that I was burning money on this project?
It was a passion project.
Well, great, that Marvell definitely didn't care about that. True enough, but,
Why it was okay with Marvell or with you?
oh yeah, why it was okay with Marvell? It was definitely okay by me. I was having a wonderful time.
But I'll just go for the basics here. Marvell was glad you were selling their chipsets.
Correct. Marvell was glad we were selling their chipset and they were glad we
Proving the
were
market.
proving a market and doing something
And
weird.
Vint, you know, he really loved the IoT stuff back then. He was probably pretty jazzed too.
Everybody was pretty yeah.
Pizza.
Yeah, so we were opening up this IoT market for Marvell. And indeed, while I sold a few hundred of these things, the most important ones were 4 that I gave away over time. One that I gave to the Whirlpool Corporation, which led to a multi-million-dollar contract. One that I gave to an unnamed printer company, and one that we gave to the Astroprint people that kind of opened up Marvell into the 3D printing space. And so this thing, we were able to spin internally as a loss leader, right? It was a marketing tool. It got to be my passion project in the maker space, while also being a loss leader for Marvell marketing and allowing them to go out and kind of get into this IoT space.
Every project I had like that, I called it tuition.
Yeah, there you go. Exactly, right? Like we were doing what we needed to do to get Marvell kicking and screaming into the IoT space. Bad news about how that story ends. Marvell got acquired in 2016. And one of the very first talks that I ever heard from the new acquisition team was by one of the people who was instrumental. If you remember around 2014, 2015, there was a big news story where a bunch of activist investors bought the Olive Garden and said that there would be no more free breadsticks. And that guy, the breadstick guy, hops on a conference call with me and says, you know, what is this IoT thing all about and why is Marvell getting into it? And by the end of the year, it was done. No more IoT at Marvell, no more Kinoma team at Marvell, no more IoT chipsets. They sold off the SoC business to Broadcom. And most of my team ended up going to Amazon and becoming the Alexa automotive team at Amazon. And by that point, we just were kind of bummed.
Wow.
Quick lessons learned from the Kinoma Create experiment. Big one that I can't spend too much time on, but it's that makers really want to add the egg. If you don't know that idiom, there's a story from Betty Crocker in the 60s, where they were selling cake mixes. And they went too far down the line of automating the cake mix, and it was a just add water thing. And people wouldn't buy it because you weren't really making a cake. And when they took out the dried egg and said, you gotta add an egg to it, people are like, I'm baking, right? It's perfect. And so hobbyist makers really want to add the egg. I can't tell you how many different people came up to me at trade shows and said, well, you did all the fun stuff. Like the stuff that I want to be doing is like making the screen work and figuring out how to connect it to the internet. And, you know, why would I use this thing? Companies, Whirlpool did not want to add the egg. They just want something that works. Most people that we found in the maker movement didn't really want to build new stuff. It was just the truth of the matter. People really enjoy going and reading about a project that works and then building their own implementation of it and having it in their home. But most people weren't waking up and saying, I'm going to invent the perfect alarm clock for Mimi. They were saying, oh, there's already this blog post about how to build gumball dispenser. I'm gonna go build that gumball dispenser. And so most Kinoma Creates that we sold either sat on a shelf and are still sitting on a shelf, or were used primarily to run code that I wrote or one of my interns wrote, where it was just demo code that we were putting out there into the world. If you were trying to build a business off of Kinoma Create, you would have gone out of business in weeks. Don't do that. Making these IoT devices meaningful was going to have to be a kind of broader initiative. We were going to have to go to manufacturers. We couldn't really rely on the maker movement to do it. And yes, my last piece of advice is try not to be the highly visible public face of an emerging technology when your company is cutting emerging technologies. Doesn't end well for you. Fast forward, we are now in 2017. The maker movement is in disrepair. The world is in a little bit of disrepair, if you remember 2017. We took a small portion of our team at Kinoma, Lizzie and I being two of the founding members, and went out and formed a new company called Moddable. Moddable still exists. Moddable is doing their thing. I have nothing but friends at Moddable. I am not here to tell you a sad story about Moddable. I'm just here to tell you a little bit of its story because I think it might be useful to you. And then we'll move on to Crowing. So as I mentioned at the top of this talk, IoT is a big business, but it is just the case that consumer IoT is broken. People don't trust devices or service providers, and the few that they do trust, they absolutely should not. Consumer confidence is eroded by services that constantly disappear. And generally speaking, devices just kind of come as they are off the shelf and work the way that they work. It's all kind of a bummer. So when we opened Moddable in 2017, it was to headlines like this. Samsung warns customers not to discuss personal information in front of smart TVs. That's a good look. Lack of trust in AI assistants could hinder adoption. How hacked water heaters could trigger mass blackouts. Music service no one wanted will no longer run on speaker no one bought. Nest's hub shutdown proves you're crazy to buy into the Internet of Things. And Maker Faire and Make Magazine, my beloveds, went out of business in 2019. Everything was kind of bleak for IoT and for the maker movement in general. And so we decided to really pivot pretty hard towards how do we bring IoT to market in a kind of ethical and sustainable way. We were very inspired by the book, The Future of the Internet and How to Stop It, which is a classic on kind of the death of the open web. We saw the same sort of processes happening in the consumer electronics space and really wanted to help in the same way that kind of Web 2.0, Web 3.0 ostensibly opened things up to more content generators. We wanted to open up IoT products in that same way. We were also very inspired by the right to repair movement and wanting people to be able to take a thermostat or a washing machine or a refrigerator and update the software on it, right? Like when you buy a computer or when you buy a phone, you're not obliged to use the stock software that came with it for the rest of your life. You should have some opportunities to customize the software running on a device, to update it, to change it, to customize it, to make my thing that is just right for you, and ideally to create some sort of marketplace around those things where you can have an app store for your oven. And I say that somewhat facetiously, but not not really. Like, I really do think that there is the like opportunity for, you know, assorted food, somebody who has a big presence on YouTube around cooking, to make an app that runs on a Whirlpool or a Samsung oven and walks you through things the way that, you know, they want you to walk through them. And being forever locked into like how one company thinks that should work is just kind of a bummer. So we went off, we founded Moddable. As with Kinoma JS at Kinoma, the primary product at Moddable is the Moddable SDK. This is a JavaScript SDK for embedded product development. It's an engine, runtime, and framework of modules targeted at embedded applications. If you walk into a Best Buy or a Home Depot today and you see a product that has a touchscreen on it that is selling for less than $1,000, I can almost guarantee you that it's one of these two companies. It's either Kinoma stuff still kicking around, or it's Moddable, because we're really kind of the only touchscreen connected device people working in the microcontroller space. I should be clear, I am no longer affiliated with this company. I do not work here, but they are friends. Yeah, you can see out here a couple examples of Moddable hardware. These you can play with afterwards. There's one just kind of going through a loop of demoing a weather app over there. And then if I unplug that, I'm going to disconnect the speakers. I'm not going to do that. Clever. But if we plug that one in later, it's running another demo. But Moddable sells this kind of hardware for people to use as a prototyping gear. This cost $150 11 years ago. This costs like $30 today. So they did a more sustainable job with their hardware design than I did, put it that way. And the Moddable platform is used in a lot of different places now. Whirlpool's Electronics, this smart massage gun thing that's sold at Target, StackChan, which is this little guy that actually has pretty broad, like you see him running around at Maker Fairs again now that Maker Fair's back, and things that's built on the Moddable SDK. And then Moddable is also in the blockchain world, doing JavaScript engines that run on blockchain.
Okay.
I'm not there
It's
anymore.
called a smart contract.
Correct. Yes, it is. More power to them. But the goal always was to kind of focus on this notion of ethical IoT and putting users in control of their products, helping manufacturers benefit from these ecosystems of apps that could run on their devices. And more than anything, what we wanted to achieve was making it so that if the cloud service goes away, you could continue using your product by getting in there and updating the software on it and allowing you to connect to your own custom cloud service or a different third-party cloud service. And the approach that we took to that is a thing that we call mods, hence the company name Moddable, which is essentially a rewritable region of Flash on these devices that is locked down and secured and can only run portions of JavaScript code that are predetermined by the developer of the appliance, using hooks kind of built into the main application. So you get like a known API for how to control an appliance, to the extent that that is safe. There are things you can't let application developers do with your washing machine, but you can let them change the colors of the LEDs. You can let them change the UI. You can let them change the cycle time, things like that. And then kind of a application interface for making those changes and applying them to running applications. So better for users because they can adapt devices to their own needs. They can really own and repair their devices, sustain them for longer, keep them running longer, even after the company stops supporting them. Better for developers because it creates this marketplace where if you're a JavaScript application developer, suddenly you might be, on Tuesday developing web apps and on Wednesday be developing refrigerator apps. And very much we have people in the ecosystem doing that. And better for manufacturers because it allows their products to kind of grow over time. That is at very least the pitch that we gave people. There is inevitably some pushback on that because not every manufacturer wants their product to stay sustained for longer. I will say, generally speaking, the partners that we worked with were pretty good about that. That was not the worldview that I really got from them. And then our kind of radical take on the world that I could and have given whole hour-long talks about is that we wanted to try to kind of force people into this world of mods and modability by giving them a discount on their license. We are open source, but with fairly restrictive copyleft licenses attached to the Moddable SDK. And we would kind of give people either it for free or at a discount if they would kind of play by the world that we wanted to see. And we would charge them full price if they didn't, and let people make that choice. And kind of the company grew off of those who paid full price while trying to encourage the other thing to happen. An additional branch of this story is that Moddable is deeply involved in ECMA International, which is the standard body that owns JavaScript, technically ECMAScript. And ECMA 419 is the embedded systems API standard. It is a international standard for how to do JavaScript on embedded devices. There are 3 implementations to my knowledge at this point, the Moddable SDK being one of them. J5E, which is targeted towards robotics, and then a small implementation that is being used for some private projects. But it continues to grow, and we're hoping to see more implementations of that. I bring up Moddable in no small part because I do think that it is actually a really legitimately good platform for courses. So if you are teaching a course where you need people to get in and build interactive devices, this is a way to do it without having to learn like a lot of hairy C. So you can get in, build your applications in JavaScript, blink lights, turn servos, operate sensors, everything else that you want to do. And it's really, really straightforward. I used this platform twice in teaching CS 160 at UC Berkeley, which is the undergraduate user interface design course. And the beauty of that course is that it's very interdisciplinary. It has, some hardcore computer scientists, but also a lot of people in cog sci and design, and people who've maybe taken like a class in Python or something, and then, come into my class. And in that class, everybody was really able to contribute because you can kind of just read JavaScript and kind of figure it out and make the little changes that you need to make. So it's a good option. It's all open source. If you have an educational project, an educational use of it in mind, email me and I'll put you in touch with the Moddable people, and they would love to work with you. So always an option. Lessons in motion from Moddable. Big companies are stable customers. They do have the potential to have massive impact, but they are painfully slow moving. It is what it is. Some people have the patience for that. I have learned that I don't. We were working on things in 2017 that still haven't made it to market, and they're going to. They're still in the pipeline, but they're going to be at a Home Depot near you in 2028 or something. So we're talking about, 10 to 15 year lead times on a lot of this stuff, and bless you if that's for you. Partnerships with small companies are kind of a roll of dice. They're fun. I like doing them. They don't usually work out. Providing the tools to make devices moddable is insufficient to really generate marketplaces of IoT apps. If you buy one of these appliances out in the world right now, it does not have an app store on it. It is still in the pipeline, and I do hope that we will see more of this soon. And a few of our smaller partners are kind of heading down that route. Yeah, please.
It's a good time to ask this simple question.
Yeah.
impact oriented or nonprofit organizations, how many are interested? How many have you hooked up with? Not really.
With Moddable,
Yeah,
we did a ton of it at Kinoma. So
Yeah.
I did a lot of partnerships with,
I was more thinking of today.
yeah, today
Is
it's
there-
pretty small, honestly.
Okay,
Frankly, Moddable is pretty small.
and they're trying to stay out of that.
No, I don't think that's right. I think they just don't have the bandwidth for it. It is the sort of thing that like, were I still there, I would probably be running that, and I'm not still there. So, they're kind of more focused on survival right now, but it's a noble role and something that spiritually is aligned with the mission. There's just not a lot of it happening right now. I do think that the path forward on this is standardization, like the ECMA standard, and perhaps regulation. It's not gonna happen anytime soon, but I would really like to see, a court-ordered solution where some of these platforms are getting opened up. There are reasons that you can run apps on your smartphones, and they are not all just decisions made by, Steve Jobs sitting in a corner. They were forced down that road, and I think the appliance manufacturers at some point kind of need to be forced down that road also. Short answer on my story as to why I left Moddable and why I'm doing what I'm doing now. The pandemic was hard on us in California. We shut down very hard in Santa Clara County, California. We were out of our office for more than 18 months. My beloved curling was shut down for more than 18 months in California. I kind of transitioned straight from that lockdown to going and helping my father go through a cancer treatment, and then went straight back out to California and just kind of thought like, I can't right now start a project that's not gonna hit the shelf for 14 years. Like I can't do it. And so I wanted to kind of pivot my life to be tighter loop, at least for now, where I would have more direct interaction with people, more direct feedback on what we were doing, and interact with people just day to day to help them live a better life. And in one direction, I'm trying to pivot back towards teaching. I would love to get involved in that here at CU. But in the current moment, I teach every day, and I teach at Rock Creek Curling. So I am curler in residence at Rock Creek Curling. That is a semi-made up job title that is somewhere between lead instructor and general manager, depending on the day. And basically, I just hang out at Rock Creek and teach people to curl. And we do, corporate events most days where people will bring out big groups. We teach them to curl. We run an intro course every couple months where we teach brand new people how to curl. I run a developmental league on Wednesday nights where I go out and I teach people to curl. And I love it, and it's wonderful. And I've had the opportunity to teach at least you to curl, I believe. Were you there too?
Yeah.
Excellent. How did you?
It was really fun.
Excellent.
Yeah.
Wonderful, wonderful. We brought, there's a conference workshop. I don't know what you call sketching, but sketching in hardware is a recurring group for people doing this kind of work that I was involved in for years. And when it was hosted here, we brought everybody out and taught them to curl at Rock Creek, which was a wonderful time. That's my story. The technical story is that there are major opportunities for doing this sort of fun maker technology work in the curling space. And I would love to recruit from here because I need expertise. I can build these things. What I am not is a robotics expert or a computer vision expert, and I need some partners on some of these things. So I'm going to pitch you on a few curling related projects. And then we're going to, you're going to go back and you're going to think, oh, Billy, who's a master's student, is the perfect person to solve Andy's problem. And then you are going to send Billy to me. So how does, that's right. Andy loves interns, damn it. So how do you make curling ice? Making curling ice is a daily cycle of subtractive and additive processes to level and make uniform a sheet of ice. This is, a 15,000 square foot chunk of ice that needs to be really, really level and is maintained with a razor sharp blade that you kind of run along the ice. You scrape it with a big 5-foot wide blade. You manually walk backwards, applying water to the ice and kind of build it back up that way. That texture is important. It's how a curling rock works. And if you screw it up, then you need to, what we call flood, which is where you just kind of boom, dump water out there and start over. That takes a couple of days because you have to reset everything after you do that, and you can only do it about 8 times a year. So you desperately want to not screw it up. Here is some video of this in action. On the left is the scraping happening, and then this is the pebbling process. Photo courtesy of me, but Sean Marlowe, my dear friend, is doing our ice out there at Rock Creek. But yeah, this is the thing that you drive around trying to make the ice perfectly flat, and then you try to put an exactly uniform pattern back down using that thing on the right. And what you can see here, if you look very carefully, is over here on the left is the pebbled surface. So that's after the water has been applied. And then right here is the line that he cut with the scraper, where it's flat over here and pebbled over here. This is the part he hasn't hit yet. And so this has to be super, 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 super precise. Anybody not involved in curling want to take a stab at how precise the ice needs to be. So a curling sheet is 150 feet long, 15 feet wide. The way that the World Curling Federation describes how flat the ice should be is relative to an ideal plane. So imagine you have an ideal plane, 150 feet by 15 feet. How far out of planar are you allowed to be to still have elite curling ice?
1/8 of an inch.
Okay, good guess, 1/8 of an inch.
20 nanometers.
Like it. We're really boxing it in here. Somebody give me the 2 inches guess and we'll have it all. So across the 15-foot cross section, you need to be within 0.5 millimeter of plane.
That's serious.
And across the 150-foot longitudinal section, you need to be within a single millimeter.
They measured.
Yeah.
Yeah.
So that's my question. Is that even possible to measure? I don't believe it. I believe that that is probably bullshit. Like,
I thought you were gonna come back and tell us you have a LiDAR system that's been set up.
no, again, you're going to build me a LiDAR system. That's what we're talking about here, people. So, yeah, I don't believe they have the technology to measure that. I reject that. But what
It's aspirational, right?
it is aspirational, for sure. And what I can tell you is that 1/8 of an inch is definitely too much. Yeah. So if you're at 1/8 of an inch, you definitely can see the curling rock do weird things, like for sure. Like that is absolutely true. And that is about as precisely as I've ever measured it. So the truth is somewhere between 0 and 1/8 of an inch, but 1/8 of an inch is pronounced. So it's closer to 0 than it is to 1/8 of an inch. The way that we actually do this in real life, and this is hard to see, is here the scraper came through, okay? And you can see right here that more of the pattern was left behind here than it was right here. That means that this spot is fractionally higher than the other spots, so the blade hit it a little bit harder. And you as an ice maker are looking for those sorts of things. You're wandering around out on the sheet of ice trying to find those spots that are, some small number of millimeters higher than the others. And again, this is a game of hide and seek in a 15,000 square foot.
I've got one word for you.
Yeah.
Hockey.
Yeah. Got it. So, boy, you anticipated the next slide. So there are what we call arena clubs out there, people that play curling on hockey ice. Hockey ice is all screwed up. It's like more than an inch often out of whack. And it's so grossly out of whack that you can actually survey using conventional surveying equipment. And that is indeed what curlers on hockey ice do. is they will go out with surveying equipment and map out the whole thing. And will come up with diagrams like this of a hockey rink telling you, okay, this part of the ice is 45/100ths of an inch above the center of the ice and that sort of thing. And then a friend of mine at Silicon Valley Curling builds these like exaggerated diagrams of what does the ice look like and how does it change over time.
So can you just give us a bit of background? So I see the shoes are there. So
Yes.
Obviously, you're not ice skating.
Sure.
So those shoes, what are the soles like?
So you have a chunk of Teflon on the bottom of a shoe that slides along on the ice. But the important bit here is actually the bottom of the rock. So the bottom of the rock is shaped like a donut. It's kind
So
of,
that's the rock, that's a.
No, the rock is
the rock is like a 42-pound
The one
chunk
that-
of granite that you, with a handle on top that you're throwing down the ice. Yes,
Is
please simulate a curling shot.
There's a picture on.
There you go.
Yeah.
I couldn't get a curling rock to bring in, but they are big chunks of granite.
You could, you wouldn't have brought it.
False, but
So are they flat? Are they
they're donut shaped on the bottom.
donut shaped on the bottom?
Yeah, and so only a small part of the rock ever touches the ice at any one point.
So that's why like a half millimeter can
Yeah.
really offset
Correct.
it. Okay.
The total square area touching the ice at any one point is maybe 4 square millimeters. Like it's a very small portion of the rock that actually interacts with the ice because it's a curved band touching textured ice, right? So very little of the rock actually interacts with the ice. It can be really deeply impacted by it.
So does a Zamboni not work in this application? Like where do you put water?
Unfortunately.
It's kind of like a hay baler.
Yeah, it's too crude a tool. So Zambonis make the ice level within about a ½ inch, and we're talking about ½ millimeter. So
Wow.
it's a real problem.
And the water droplets can only like penetrate a ½ millimeter.
They're about 2 millimeters tall, but they're pretty uniform. So whatever is underneath them is what dominates. Yeah, it's miserable. Tell me about it. So as some of you said, I would love a like LiDAR or a robot that drives around and measures, where we're, how tall the ice is, although sub-millimeter awfully hard with like time of flight sensors, that's not happening. And so I don't have the technology to do this, like in my world. I need somebody to come up with like a really good idea for how to survey the ice. And I'm not here to tell you the answer. I don't have it.
Work with cardboard here.
We start there. Yeah. A few other technology things that happen in curling. So that's the ice one. We do coach
We
sweeping.
started with the easy one, right? Exactly.
I started with the important one. We coach sweeping using load cells in a broom. So you can, when you sweep, you're supposed to be putting like most of your body weight down on the broom and keep sweeping away. This is a training tool to help you see to what extent you are getting all of your weight down on the broom. There is technology, but I would like to build new technology for tracking the release of the rock. So when you let go of the rock, getting it straight in the line that you're sliding on is very important. People have a tendency to kind of pitch it in or pitch it out, roll over it. And so giving real-time feedback on when you're doing that is something that I'm interested in this kind of, maker world. And then the one that I really want to figure out, talk to your friends, is how to do projection onto the ice. So this is the brightest room in the entire world. And I would like to find some way to project paths onto the ice to help in coaching, because what you want to do is be able to say, like, let's look at what that rock 2 minutes ago did and show the path of the rock, right? Wouldn't it be sick? But I have no idea how to do it. I think it involves lasers, but I don't know how to do it. Yeah. It involves, yes, lasers, rocks with freaking lasers. So I'm working on figuring out like, what does that look like? How do we build a solution where we track moving rocks using like a vision solution or a gyroscopic solution or something, and then project onto the ice what that rock just did. You can see the vision. I just don't know how to do it. And then the holy grail here would be a computer vision system that allows you to recreate the whole game. There is good curling simulation software. A friend of mine in California built this thing called curling.gg. I would love to be able to just go upstairs after a game and say, hey, you remember what happened in the fourth end, that third shot? Let's pull that situation up and then like try a couple different other ideas, rethrow those rocks and see where it goes, that sort of thing. So that I think is a computer vision solution with cameras mounted around. It just needs to be built, but it would be the coolest thing in the entire world if we could figure out how to build it. And if we commercialized it, we would sell dozens of it. Dozens. The global curling market is indeed dozens.
You're gonna need Taylor Swift.
I've been saying that, but
That's marketing.
then on the kind of, cardboard and blinking light side of things, curling is a beautiful sport. It sounds cool, it looks cool. There's a lot of opportunity for like putting LEDs on rocks, for making rocks glow when they get hit. I would like to make rocks scream when they get hit. I think that would be fun. There's a lot of room for kind of creative aesthetic engagement around the sport of curling. And I've done a lot of kind of technology at Rock Creek around community building. I ran a whole Bonspiel last year where the joke of the Bonspiel was that it was like AI generating a false history of Rock Creek curling. So we celebrated Rock Creek Curling's 100th anniversary last year, 3 years after we opened, and built out this whole 100-year history of Rock Creek, including albums and a mascot that was introduced in 1977, Creaky the Rock Creek Curling Trout, who now exists in real life and is embedded in the ice. And my perhaps proudest accomplishment of the past 3 years is that if you ask Google, when did curling start in Colorado, Gemini will confidently tell you that curling was first played in Colorado on May 3rd, 1925 by the Rock Creek Curling Organization through the discovery of curling stones in Lafayette by children working in the mines. So take that. But yeah, my charge to everybody.
AI is not humorous.
That's right. My charge to everybody is to bring back the maker movement. I miss it. Like, I miss people building cool things, building things that are meaningful to their lives, building stuff that matters. Like, we're also burnt out on like the sucky parts of technology, that we go to this kind of creative direction, right? But there is some middle ground there where we can build creative technologies that are meaningful to us, but also like pragmatic and, can be sold. Bring back the maker movement.
Yeah.
What will you create? Go out and build something cool. Thank you, guys.